90 RCs, I can explain that. It's young me at the moment. Okay, so slightly different sort of direction I'm trying to take here. If you have worked on some protocol designs yourself, then you may have noticed that things have changed quite a bit in the industry over the, let's say, last 20 years in the way how we design protocols. It has actually gotten pretty complex because as a protocol designer, you are asked to do a lot of different things. Now, in this workshop, we are primarily focusing on formal methods, but that's not the only ask. There's a long history, and this list is not completed just in a presentation, just to give you a glance of what a protocol designer typically needs to think about. There are guidelines. This is focused primarily on the IETF, which also publishes a lot of guidelines for better designs. There are privacy considerations, which I happen to have contributed, also part of a workshop. There are related considerations that were published also as part of the Snowden revelations, for example. Of course, security considerations with the way how we do threat modeling, how we create security requirements, or in general, how we even write documents to provide the right level of abstraction to a proper analysis, because it's easy to get lost in the details. And later on, there were other considerations added, like operational considerations, because ultimately we want to deploy this stuff in a proper way. More recently, energy considerations, not just for IoT, which may be battery-powered devices, where it's a little bit obvious that you may want to take that into account, but also, like now with more focus on sustainability, we want to incorporate those. Extensibility, there's the desire or the need for some of the groups to actually have a lot of implementation experience, so you're not going to specify or to publish this specification or standard, the final standard, without having multiple interoperable specifications. So which is like a non-trivial burden during the development of a specification. So for example, in the OWASP working group, which I co-chair with Ripard, we have often more than 10, sometimes up to 20 implementations of a specification at the time when the specification gets published. Like it's like some of the stuff is widely deployed at the time when we publish the spec. And similar, there's extensibility and various other considerations that focus on deployment success, which is a very complicated topic, relates to incentives, some of which we talked about here as well. So there's a lot to think about, and now we are adding formal methods to this whole game. And so if you have either participated or dived into the last week's IETF meeting, which took place in Australia and Brisbane, the TLS working group made another sort of step towards mandating the use of formal methods in the development of specifications. It had already a good track record with the work on formal analysis and with TLS 1.3, as some of the previous speakers have mentioned. But now it's being sort of de facto mandated for all non-trivial extensions. And the ask is to the authors of specifications to do that formal analysis early in the process. And you can listen to the discussion yourself. And there was even a candidate mentioned during that presentation. Before I gave my presentation about another proposal, independent of what we discussed so far, it's a key update mechanism. And it was like, oh, it's non-trivial. You need to now come up with a formal analysis as well, in addition to the implementations, in addition to all the other things that I showed on the previous slide. So it's a lot of work. And this sort of shift has, I think, also been motivated by what we saw in this IIDF research group that a few speakers mentioned, which is looking at formal methods and making them more usable within the standards process. I don't think we are quite there yet, but I think it's a good attempt. But there's obviously a lot of challenges that remain, and I will talk about a few ones that I noticed in my work, and maybe some of you can actually help with those challenges. One is, and I think that's a shift in the way we have to work in the future. So when I was chairing the OWASP working groups for a very long time already, and we had at one point, we had some researchers from the University of Trier coming to us and saying like they have discovered some issues using formal analysis in OWASP. And so I started off created a workshop to discuss all of this, which then led into a workshop series that's still ongoing today. And that sort of effort was driven by the fact that the work was done in OWASP. It was basically completed specifications, and then researchers came in and looked at those documents. They obviously had something, what was presented in the tutorial yesterday as a final written specification, hopefully readable, hopefully good, but it was completed. And so it was an easy target in some sense for researchers to analyze. But now we want to have something much earlier in the process. We want to start right at the beginning, as I explained from the DLS mailing list, or from the DLS speaking. And they are, for anyone who has participated in standards, it's a back and forth. It's like the process is non-linear. It's sort of like it changes all the time. It's like extension, like the design approach may totally change many times during the whole life cycle. And the DLS 1.3 standardization work wasn't any different. It wasn't quite clear at the beginning for those who had contributed to that work where the whole thing would end up. It wasn't like the grand roadmap and that's what we want to do here, requirements, but instead it was like change it here, no, not quite, like constant up and down. And I worked very on an implementation, and I had to change it like 20 times, like totally annoying, like a huge time effort. And if you spend the same amount of time on asking researchers to spend like these 10 years, come along and analyze DLS with us for 10 years, and you do it 20 times because we changed our mind along the way, you would probably get very frustrated. So I'm a little worried about the incentives and how we do this practically, or whether we need to educate the standards community to actually really do it themselves with the limited amount of time they actually have doing all the other things. Because I think it's a big ask to the community here to hang around for, let's say, at least 5 years, which is as long as it takes to write a specification from start to finish, to follow along and to sort of contribute and to do the analysis. I think there's something that has to happen here. And then even when you are done with something like DLS 1.3, it's not over yet, because then all the extension starts. And then with every extension by itself, it's just one small little thing, but then it piles up because the extensions pile on each other, and having a good way to compose various different protocols is I think still missing on a formal method side, and also it's even difficult on an implementation, on the implementation front. So I try to indicate that here with these simple bubbles here, but if you take some specific examples, you will very quickly see how difficult it is if you take an encrypted client hello, which extends DLS 1.3, and then pile on, let's say, the extension I just mentioned, the key update extension, on top of this, and maybe some other extensions, and want to verify everything to see whether there's some unwanted interactions between them, which is where typically the problems are when you look at corner cases that people haven't considered at the time of the design. Another challenge is the scope of the whole analysis. And unfortunately, the way we chunk up work in standards is not the way how people would approach it from a formal analysis point of view. I'll show you that based on the CSR attestation and some of the follow-up work that use the same mechanisms. So what is this attested CSR? I'm sure you are familiar with the BK's work and all these the great standards for certificates, X509 certificates, and there's all this management of those certificates sort of bolted onto it. And one of them is the certificate signing request, which there are different formats. Probably the most popular one or the most widely used one is the BKCSM format. And so we wanted to use that as a vehicle to add evidence so we can provide something here at the stage which I will explain in the next slide. And that work became a working group item in one of the IDF working groups, and you can have a look at it here. It's actually very simple because it's more or less conveying some attestation evidence in the certificate signing request. But it attracted a lot of companies, and like I listed a couple of them here, and a couple of different players from the HSM community, CA communities, and so on. Lots of guys, mainly because there was suddenly some industry pressure from the CA browser forum, which demanded that a code signing certificate, or those issuing code signing certificate, needs to demonstrate that the keys are not walking away, so they are generated, stored in the HSM and never get exported in the clear. That's sort of the ask from the CA browser forum. You're probably familiar with the work of the CA browser forum before the work on the web ETL. And they want to be quite unrealistic, as some of those organizations are. They basically wanted it in a couple of months, so the design team started early last year, and they wanted the final result in June. Like anyone who's familiar with standards process thinks that this is completely unrealistic, and of course it is. But there were two problems of like, how is this supposed to work? How should an HSM prove this to a CA that these keys are really inside this HSM? And of course, the verifier or the CA, the verifier part of the CA has to accept some of those sort of some evidence in some form. And this is how this works conceptually. So the certificate signing request is a way, so you normally generate a public-private key pair, you put the public key into that certificate signing request alongside some other information, and you ask the CA to give you a certificate in return, and you then typically need to demonstrate the possession of the private key corresponding to the public key that's in this certificate signing request. And then you may also need to provide a proof of identity, which is then a separate part. But here you see this evidence included in here, which has typically some platform attestation evidence, and also has this key attestation evidence to indicate that this is some information about the key. And this whole thing gets then signed by this attestation key, which was originally signed by the HSM manufacturer, which has that component in there. So if you're familiar with the RATS architecture, this is probably unsurprising. So where is this work? So it's a very narrowly scoped effort where someone can immediately see that there's some other pieces around it that need to also be in place in order for this to work. So we met at the last IDF meeting. We did a hackathon, a very common thing these days. Like we sit together, write some code, try to fix some open issues. There's some code we work on specifically to make this work with the BPM. So in the appendix, there are two examples. One using the BSA attestation, BSA attestation, and the other one is using a DPM-based example. And we hack this DPM-based example together and look at the code and see how that works. It's surprisingly complicated, given that DPMs are around for a little while already. But as Ionut was explaining, just a minute ago, a lot of the work previously has focused on the attestation technologies like DICE and DPM and so on, but they didn't focus on how to get all the evidence and the attestation-related information off the device and ship it somewhere else. And that's why we have these discussions about how do we stick some of that into protocols like DLS and so on. So it's like we are working our way through the chain of things, and so this DPM stuff hasn't really worked out. So it's basically left as an exercise to read on how you would do that. And yeah, we went through it with a bunch of the Mount Weissman was one of the persons with us who has been 20 years in the DCG, so obviously an advantage that probably other people don't have when they design their systems. But luckily we did. So it only takes a hackathon, 2 days, and not several weeks or months. So how does then, if we take that up to a bigger level, and that's the scope you typically have, and the drafts are indicating like some of the work in progress and that's still going on. So there are lots of moving parts, and Thomas was talking about one of those moving parts. But that's, if you want to do an analysis, you need to decide about where does the scope start and where does it end. You can make yourself your life very easy if you just keep it small enough. But then what's the meaning of it ultimately? Because you need to look at the whole chain, different security properties when you stick the pieces together. It's supposed to work like Lego, but it's not quite Lego because the boxes are not completely replaceable while maintaining the same security properties. That's the challenge. How do we solve that challenge as in a formal method community? Is something that is still beyond. And you see the CSR attestation, which I just talked about in the last few slides. That's one little piece in this sort of flow, which I marked in item 2. But then you need freshness, you need nonce, you need to merge this into a certificate management protocol, which has its own sort of issues like ESD, CMD, and so on, or ACME, and etc. You need to interact with the verifier like Verizon. Verizon needs to get all the data. There's attestation result, as we heard yesterday from Trustee. You need to get that different shapes. And then on the left-hand side, you see all the different ways how attestation technologies produce different formats, secure the formats, put all sorts of information in it. So what looks like, if you look at the CSR attestation document, looks like a very simple problem, very quickly turns into something that's very complicated. And if you try to implement this in an end-to-end scenario, it will take you a couple of months. Let me give you another example, one that actually quite nicely fits into what we talked about earlier with the provisioning of trusted execution environments. It was Samuel who talked about it yesterday. Let me tell you what DEEP is, the Trusted Execution Environment Provisioning Protocol. From his description yesterday, he was talking about the way how a DE gets these keys for the confidential virtual machine that he wanted to secure. He needed a key distribution mechanism in some sense, and probably configuration information and probably software as well. And he used an HTTP-based protocol. This is something like that. It provides that communication from a DE to this trusted application manager to get that information. And it uses the RATS architecture, it uses the evidence. It doesn't talk about key attestation because that was work done just recently. But it also allows to provision then information into that DE in either just signed data or also encrypted data. Here's this model. The diagram, you see the same pictures as before, the secure word, known word, the DEs in there, and now these trusted applications need to be provisioned with these with software, with the credentials, with configuration information, and so on. And the complication that is added here is that you actually do the attestation, not like we heard yesterday, where the D is attested to the server-side infrastructure, but it's actually in both directions, because the DE also wants to know whether it's talking to a genuine, a trusted application manager, specifically when it gets all that software and keys provisioned to it. And so, but those are separate pieces in a typical system, because there are other parties providing the software, providing the keys, providing configuration information. They don't come from the application server directly, they come from someone else. I call it here also, could be a developer, it could be some company, it could be anything. And then there's also the verifier involved in this whole picture. So how do you verify a system as complicated as this, where this is only one scenario, combining a couple of existing technologies together, technologies which we talked about, like the HTTP with TLS, we talked about the RATS architecture evidence, we talked about the suit. In this case, it actually uses the suit mechanism for distributing the secrets, the software. Thomas was talking about this a minute earlier. So even if you have analyzed the building blocks individually, can you put them together? Likewise, someone was yesterday saying, telling Samuel, why do you use OWASP for the provisioning in these virtual machines? And there is a document in OWASP that adds attestation to OWASP, not just for this virtual machine, confidential machine setup, but this is a use case for smartphones, for the wallets. The European Commission is working on these digital wallets and these EIDAS and all these identity management things. And so you obviously want that too. So a couple of different use cases there. And so what I just mentioned about Attested CSR, this is essentially the application of it in OWASP, just with not a different format. So in OWASP, there's some excitement around the use of JWTs, JSON Web Tokens, and JSON in general. But otherwise, it's the same concept again. But OWASP has this interesting nuance that it's embedded in different environments. So if you put OWASP into a web browser, like a classic web usage, it's very different because you inherit all the side effects of the web browser security model. But if you go to the native app, it's again very different. If you put it into, as I will show on the next slide, if you put it into a workload, in a workload like a Kubernetes environment, again, a very different usage environment. So you have these different, sort of this one protocol, but then different security properties as you sort of put them into a different context. And I mentioned the workshop, the security workshop already, but there's also in this IOTF group, there's a collection of papers for the analysis of OWASP in these different environments. But they are often, this security analysis is often done very late in the process because the reward is so much higher for researchers than having them involved right from the beginning. This for us very difficult. So maybe you have some ideas on how to do that. And this is the last example where we would also appreciate how this is very new work. So it shows sort of the spectrum of the more mature, essentially completed work like Heat, where we also have examples for Riff formal verification, and also Xamarin. It's almost like a training material, if you will, if you want to compare it. Versus something like this, which has just been started. Last week, there was the first working group session on what is called workload identity multi-system environments, or WIMSI. It's essentially the spectrum of workloads running on hosts, whether it's a confidential computing platform or just a regular Kubernetes deployment. But they all have the need to provision the workloads with identities or with credentials between many cases come either as JSON web tokens or as X509 certificates, depending on the applications you use afterwards between these workloads. And so there's simply, in a simplified form, you have some agent, you've seen that picture before, agent talking to some control plane entity, depending on your favorite technology. These entities have different names. And you may use attestation to get some credentials downloaded to the agent. The agent then, as it starts the workloads or interacts with the workloads, it provisions those credentials to the workloads. There are different techniques to do so, like system environment variables or local or domain sockets. Or you could look at Spiffy, Spire with the domain socket. If you use Kubernetes, you use a file system or system environment variables, and so on. But there's a sort of a generic pattern here that we can study. How can we analyze a system like this, where there's an intersection between protocols and some local communication, which obviously someone looking at operating system security will find that very exciting as well. And then there's the usual OAuth standards and communication exchange. So this gets me to the end with these examples. So we'll see more formal methods, or we will see more formal methods in the standards environments, because it's just a sign of maturing of an industry. So we definitely need more expertise in that environment. So how do we get that expertise? And hopefully some of you will help doing so. We also need to start the analysis much earlier in the process. And how can we incentivize researchers to actually help us do that? Because they primarily want to write papers and not really help out with the standards work, right? After all, PhD students are not really, they don't get credits for producing RFCs, although in my opinion, that for many don't. It depends on the universities. But probably the writing an RFC takes much longer than doing a PhD anyway, so so it's maybe not really a win again. And in case of these two examples that I presented at the end, I'm hoping that I made some of you curious and hopefully encourage you to participate, even though it's like bleeding edge, really early work. But there's at least on the positive side, there's a good chance to influence the direction it takes, and I think that's also worth something to contribute to some standards, and maybe standards that will be in widespread use in the future. So, and with that, I'd like to conclude, and hopefully you guys saw some of the challenges that we have with these sort of complicated ecosystems of standards. Thank you.
We need some cognitive scientists coming to the floor, just figure out what's going on. Going back many years ago, I did E-method and Z. I have a certificate from the therapist now. What we noticed was every time we work with formal methods people, sorry to all formal methods people, but you'll understand, is we would get complaints back saying, for example, with B, how many levels of refinement we used? We said, no, we didn't. We just worked on some pre-post conditions and maybe, well, that's not sufficient. Your proofs are too simple. You need at least 20 levels of refinement. We take it seriously. I'm thinking, now, writing down, say, the 3 API calls and their pre-post conditions took us 6 months, but generated so much discussion about what we were doing. The value of thinking in a formal way was much, much greater to us than actually getting all the proofs. And if we did get the proof stage, it just happened much, much later, and then it wasn't good enough for certain formal people. So that needs to be taken into consideration. that just writing down the API calls or function calls with their parameters, with their types, with their pre-post conditions is immensely valuable right at the start, but it's not sufficient for that nice paper in the formal methods international journal. That's where we're getting stuck. But the fact of writing this stuff down really, really benefits the whole process from the beginning. So that needs to be changed, and the value of doing that from the academic side needs to be taken into consideration. But there are some other things that can be done.
Let me respond to that one first. So I fully agree with what you said. Like I can see the benefits of sort of the early involvement of researchers working on formal methods, and I see that. Like we've been working with Osama and the DELS, and like he has been calling us out numerous times on like how sloppy our writing was, and like what exactly are the security properties that we are claiming to provide, and that was tremendously helpful. Thanks a lot, Osama. On the other hand, of course, I think the value for Osama, on the other hand, it's a little bit more difficult to qualify because like he spent a lot of time with us, sort of going back and forth, and that doesn't lead to a paper for him, or it doesn't lead to any recognition in sort of like in these academic circles, unfortunately. So that's the tricky part, I think. Like for us, like super great if we could be more rigorous about specifying on what properties we claim we provide. Very few specifications provide those detailed descriptions. Here, let's 103 that Vegas does so. It provides those, but obviously after a lot of back and forth with that community. But if you look at many other specifications, like there's pretty much nothing. Like you can second guess what the rationale is, right? Sorry, now I interrupted you.
So I think you want to.
I went to the data tracker to check one for TLS to welfare from 00 to finish it was 4 years. Gives you right. And there were 9 formal methods, over between 15 and 17. So in 2 years, there was massive market. Clearly, TLS 1.3 was a huge standard, right? So there's a big incentive. You don't even have the amount to do this. You have remaining tenants for a long time. So another problem might be the same benefit. Yeah, we really need to do this kind of multidisciplinary team. So I was making a comment yesterday about the techniques. It's not the same thing because there's much more than reverse engineering something, but there is also this reverse engineering aspects. It's also your work. So, really how to create this. I'm happy that for us it works, and I'm sure how to replicate more on this game is, it's now requirement for certain what we use, and it's naturally goes to the whole.
Yeah, that's a like ELS is obviously a high profile protocol. Like everyone knew when the work was started that this would be like ELS 103 knew that this would be relevant. And so it was obviously had advantages that most other protocol designs don't have. In OWASP, it's probably the second widest protocol, so it probably benefits from that too. And Rifa and I have sort of supported grants and also supported with in writing project proposals and so on, funding proposals to actually make that happen, have researchers look specifically at some of the specifications. but then there's a long tail, and it would be good to cover those well rather than the shining stars.
Yes, very interesting. I think I can't add much more to what Thomas said. I exactly the same points. The formal methods are difficult, expensive to apply, so I can't solve your motivation or resource problem. People time in this. But I also wanted to suggest, so you have in the IATF website the Git records to the implementations, right? So by the time you manage to get there a Git repository with protocol specification for a tool of your choice, Google or one of the model-based tools, right? This will probably then force everyone or encourage everyone and be a good example for everyone to also do it this way, like more machine readable specifications. So the best, but
Yeah, that's a very good point. We've just recently discovered that one of the RFCs published is the page that's locked. So we'll need to do something about this because most likely there will be some progress and we could add things along the way. But you're right, that will help us get people to reuse existing work and hopefully also peer review or review that work more, because that's also something that is not yet at the ideal state, because very few people actually review those results and update them because they are a little bit they patch together and then you are left on your own. So it's kind of the documentation aspect combined with what you've been saying. So yeah, I think that's definitely promising knowledge.
and whether someone who's forward to see my microphone. I don't know, I think when you look people that did TLS very people, if you like recruit them and tell them in advance that this is happening, would you be interested in?
Yeah, but of course, we do that, like we like if you raise your hand at one point in time, we will, like, there's no chance to escape, essentially. And some of them actually, it's a very positive experience, and maybe this is something to be conveyed to students, because some of the people who have been involved with the formal analysis, specifically I'm thinking about OWASP, they later were hired by the companies working in that space, and they are now sort of like the stars in a community. So that's a good entry point into some of that industry, because whenever you start new, you obviously like have to contribute something first to then be sort of recognized and respected. Basically, they need to run, sort of walk and then run, so to speak.
So there is some comments about the work of working groups. So I'm from the university which did the analysis, and they also all of them were pen and paper models. So the problem with getting into this early in the stage is that if you change the protocol in any way, you need to model and do everything again, and it's really complicated and time consuming. So I think that's really problematic for researchers to go to that in an early stage. And maybe we could change this with mechanized analysis, but I think none of the tools are there yet to analyze protocols on web level, for example, or where browser mechanism and stuff like that is involved. So far, that's a really big problem, I guess.
Yeah. Good point that you brought up. It's maybe something that has to be where the tools have to evolve and get better to be a little bit more realistic to the underlying sort of environment in which we apply this to. That's sort of what I tried to mention with this deployment variants. So as you said, like in the browser, different case, we have OWASP usage also in sort of cross-device flows, very different environment where the flow, the interaction dances back and forth between different devices, totally different security assumptions. In modeling this, or getting the support from the tools is obviously funded is obviously super important because otherwise you run into exactly that problem, which then, in that case, you really have to wait till the product work is finished because you can. I remember it took Daniel and Ralph maybe like half a year to do the pen and paper sort of analysis, and that's a long time. Like if I think about like anyone working in industry, thinking about spending half a year just on the analysis of a product is like completely unrealistic. Like you get half a year to do 5 projects, that's it.
Yeah, maybe another comment about things. So web browsers are at least standardized most of the technologies they use there. But on platform, if you look at if you want to model how apps work, that's a whole other different story because there you have Android, you have iOS, they use completely different technologies. They update it every year, so it's really hard to even build a model because if you build a model, it's already obsolete because they published a new version.
Right. Yeah, that's also like a challenge for protocol designers. So the environment you assume your technology works in keeps changing, even without being told that it changes. Like in OWASP, that happened a couple of times when the security models of apps changed considerably. Now we are facing yet another change with this federated credential management that some of the guys, Google and others, want to introduce. And so, which has an impact on the redirect flows in OWASP. So, sort of, you have an existing protocol, nothing changed from a protocol point of view, but the environment in which it operates in changes, and so does the security model. And so it's really tricky. Yeah. Thanks for adding more challenges. We can already get objects.
So I think my company goes in a similar direction. You mentioned that it's challenging to involve people during the development of the standard because they would have to redo their efforts because it's a fast-moving target. What's your position on integrating a formal definition into the RFCs right away? I mean, if you could take the RFC, then throw it into a tool, this would be helpful and would speed up the process. And also, you might be forced to actually state your requirements and your goals formally.
That's an interesting idea. I don't think I've heard that too often, to be honest. That would be, I think it would be worth a try. I would be curious on how this would look like and would like to see the reaction. I remember I think it was in 2003 when or 2005, I gave a presentation to the security area meeting, which is a side meeting, and suggesting to use formal methods in the IETF. And at that time, Avispa was a popular tool. And as an example, I included Avispa sort of analysis of a protocol in one of the documents. And I was met with huge resistance. I would say shock. So I would be really curious on the face expressions when that gets presented. But yeah, I think it would be worth a try. The RC itself may have security vulnerabilities. Maybe it's executable code.
The interesting point that this is the machine reading specs. So all the diagrams in the IETF specs are these nice, beautiful pieces of ASCII art. We've already seen machine readable versions of these because this gentleman here actually did it. All these diagrams were generated using a tool at the ASCII art. Beautiful, by the way, that generate pictures. I mean, if we can generate PNGs or whatever, why not the whole structure performance spec? I mean, you're going to get at least the structure. Might not be perfect, and at least for languages like B, you have 2 boxes attached by a line. That's the start of the whole refinement process. But if you get that initial start, it's not going to be beautiful. It's going to be missing the pre-post conditions and a lot of the names, but it's feasible. Listen,
just want to say that there's a group for that.
Probably worked out a solution for that one.
You just coded it.
Yeah, there's a tool for that, but it works the other way. You give it text, it's like random. Use the parser. It's quite simple, I'm sure. Right.
So what you're saying is you write the formal spec and then produce the diagrams. That solved it.
Yeah.
That sounds.
So one quick question on my side. So there is always a overlap between the RATS working group and the TLS working group, both meetings happening in parallel, just like the last meeting last week. So I missed all the discussion in the TLS before I was in RATS. So you said that it was made mandatory for non-trivial. So how did the working group or the chairs or the overall consensus was for what to be considered as non-trivial extension of TLS? Was it decided or?
Yeah. So the idea was to have a panel to evaluate that. So presumably some didn't say who would be on that panel, but presumably a couple of the usual suspects from the TLS working group who would basically do a sort of a basic test, like does it register a few values in IANA registry? Fine. Does it suddenly add something to the key derivation? Panic. That type of distinction.
So the panel will basically define whether it's non-trivial or trivial. Any fun?
All right, Attested TLS would be belong to the non-trivial category.
Yeah, for sure. For sure. So if you go back to the reusing architecture, history, but it's much complex. Because you need also to consider multiple different domain domains and interaction between things, how the transitions are in one domain, complex with transitions are in another domain, density can be. And this is a very, very interesting, I think. It's in the context of forward history, because it demands different in terms of not just one component, but we forces me to look at the whole system, from a system perspective or from protocol perspective. And for example, the mechanisms behind the organization token, the TLS usually a section. These are great examples of how you might end up to combine multiple models, TLS for a model with the thing one single model. So a usable library of for a model. So I think it's something that the surgeon importance is something that looking at or I'm not sure about the chat, so plus people.
I think Samuel described it quite nicely yesterday, where he was saying there's a lot of different solutions and a lot of sort of fixes run. And that's unfortunately, like if you look at existing reference implementations, like in Inspire, you look at some of the Kubernetes things, there's, which is very common in our field, that everyone comes up with new terminology. They don't make any reference to existing work, so you have a hard time understanding on how it relates, and you need to find a long way through this jungle of marketing track to really find like what is the stuff really doing, and you need to look at code, the documentation is offered, etc. And I think if just one thing comes out of this code effort, even if there's no new protocol or anything essentially defined, if there's some better description of the security properties of this system, I'm already happy. This is really a terrorist state we are in this workload identity ecosystem. So I think it's worthwhile for specifically for researchers because it's early days. So.
So one question about formal specification, no formal method to specify specifications. For me would be the first question, in which language are we doing this? Because if we write in a specification, we want to send a post request with a Euro token and some JSON in there. I don't think we have a tool currently who can do that in a formal way. Or at least I don't know one, so that would be interesting if somebody can tell something about it.
There's expect.
Thanks.
Expect.